And if you take this time domain analysis, this is also an interesting topic. There is a continuation. Okay, you will have first order system, then second order system. In the second order system, we will be discussing many things. And in underdamped system, again, we will be discussing many things. Okay, now I'm going with the first problem. I'm going with the first problem. A closed loop transfer function is given. Closed loop transfer function is given. Okay, certain second order unity feedback control system. Unity feedback control system. Determine the type of damping. Determine the type of damping. So if you see here, closed loop system is given. Closed loop system is given. This is G of S and H of S. Input is R of S. Output is C of S. You need not apply G by 1 plus GH. They have already given. Okay, closed loop system means already that G by 1 plus GH is applied. So C of S by R of S, which is G by 1 plus GH, that is given in the problem. Okay, that is given in the problem. The general format, okay, C of S by R of S, closed loop transfer function. Closed loop transfer function. The general format is omega n square by s square plus 2 eta omega ns plus omega n square. This formula you have to by heart. Okay, there is no other go. I am putting this in box. I am putting this in box. This formula is very, very important. This is closed loop transfer function. Second order system, closed loop transfer function. Okay. Now you can compare this with the given equation. You can compare this with the given equation. Okay. So after comparing, okay, we will get omega n square. We are having a value 8. You can just compare these two. Okay, compare these two equations. The box RHS and the given question RHS. Okay, given equation RHS and whatever I have kept in box RHS you compare. In the place of omega n square we are having 8. Okay, and now if you see omega n value equal to 2 root 2. If you apply square root on both sides, omega n value equal to 2 root 2. Okay, then denominator you check. I'm just comparing these two. Okay, if I check the denominator, 3s is present and here I have 2 eta omega n s. Okay, so 3s is nothing but 2 eta omega n s. I want eta value calculation. I am just doing eta value calculation. S and s gets cancelled and then 3 equal to 2 times eta. Omega n already we have calculated above, so 2 root 2. Now eta value is nothing but 3 divided by 4 into root 2. 3 divided by 4 into root 2. Okay. Now you can see 3 by 4 is 0.75. 3 by 4 is 0.75 divided by root 2. Divided by root 2. Okay. Now root 2 means we already know 1.414. 1.414. You can also use calculator in the exams. Virtual calculator will be given. You can apply and try it. However, you can see this value is not equal to 0, but not equal to 1 also. Okay, this value, eta value, whatever we are calculating, the value is between 0 to 1, we can say. Between 0 to 1, we can say. Okay, it is not equal to 0, not equal to 1. It will not be equal to 1 because denominator is greater than 1. Denominator is greater than 1. So definitely final calculation, you can operate and check. We will not have any value greater than 1 or equal to 1. Okay. So if this is the case, this is called underdamped system. Okay. So what they are asking in the question, determine the type of damping. So eta value 0 to 1 is the answer. 0 to 1 is the answer. Okay. And type of damping, it is underdamping. It is underdamped system. Okay, type of damping is underdamped system. I'm going to next problem. The closed loop transfer function, the closed loop transfer function of a second order unity feedback system. Unity feedback means already we know h of s equal to 1. Okay, so feedback, unity feedback means h equal to 1. Unity feedback means h equal to 1. If h is 1, g by 1 plus g. H value is 1. Okay, same thing here also given. Unity feedback here also it is given in the previous problem. And in the next problem also they have given unity feedback. Okay, but we need not do any calculation. Already the given thing is closed loop transfer function. It is mentioned in the question itself. It is closed loop transfer function. Okay, now you compare this with the standard formula. Closed loop transfer function, you have to remember the formula. It is omega n square by s square plus 2 eta omega ns plus omega n square. This is the standard closed loop transfer function in second order system. Now you compare. Now upon comparison, what will happen? You can just compare. Okay, after comparison, we will have numerator omega n square. We are having a value 2. So if you apply square root on both sides, omega n value is root 2. Omega n is natural frequency. Omega n is natural frequency. Next, you compare the denominator. Compare the denominator. Third term, it is again numerator only. Same third term in denominator, it is same as numerator. So no need of comparing again. First term, both the things s square is there. In the second term denominator, you can see 4s is nothing but 4s is nothing but 2 eta omega n s. S and s you can cancel. Okay, and here 2 and 2 you can cancel. So left side we are having 2, right side eta omega n. So 2 and omega n value we already calculated, it is root 2. Okay, now what we have? Eta value is nothing but 2 divided by root 2. 2 divided by root 2. So the answer is root 2. Answer is root 2. Okay, numerator 2 can be written as root 2 into root 2. Numerator 2 can be written as root 2 into root 2. So the one root 2 will get cancelled. We are left out with root 2. We know the value, it is 1.414. Root 2 value in calculator you can operate and check. Or we remember it from class 3, 4, 5th class itself. So 1.414. So this is eta value. So what we can conclude from this, eta value is greater than 1. Greater than 1 means it is called overdamped system. Greater than 1 means it is called overdamped system. Okay. Now what is the type of damping? Eta value greater than 1 is the answer. Greater than 1, overdamping is the answer. Okay. So we have done 2 problems. Type of damping we have calculated. Okay. We have done 2 problems. Type of damping we calculated. It is very, very easy. It is very, very easy. You need not by heart anything.